2, part 2. You might remember we had done those labs, the one about the tiles for the spa, and the one about the infections of the flu, and the one for handwriting your signature and timing it. And now what we're asking to do is represent that data. It says you collected data for 3 situations, so go ahead and use these resources pages and record that data. So what might make sense, and I have to close this so that I can turn around and reopen it, is to get something like this, but I'm gonna get it in here so that I can write on it. So we get something like this, and if you'll recall, we said you could go a 1x36 or a 2x18 or a 3x12 or a 4x9, 6x6, 9x4, 12x3, 18x2, and 36x1. So when we graph these, 1x36 is going to go right here. There is no 0, right? 2x18 is going to be right here. A 3x12, a 4x9, a 6x6, a 9x4. So we get a pretty cool shape here. We're getting this kind of curved shape. And the question is, should we connect these dots? And I would say no, we're not allowed to break the tiles, right? So a couple things. It says describe the graph. Well, we'll talk about this more later, but essentially it's obviously a curve. I don't think we should connect the dots because we can't have partial tiles. We don't have a y-intercept or an x-intercept because we'll never have a width or a length of 0. And then it asks us, give the coordinates or point x equals 3. Well, 3 obviously ends up being 3, 12. Now, for the flu epidemic, we could represent on this, well, actually, I guess I may as well. So we had 6, 18, 54, 162, 486, 1458, and 4374. So I won't be perfect on this, but 0 to, you can see our scale is so big, it's going to be hard to sort of figure out exactly where 2 and 6 are, but we know that they're slowly rising. I think that these are probably already too high, but that's okay. I mean, you'll get the idea, I think, of what it is that we're talking about. 5 is 486, 6 is 1458, and 7 was 43 something, so obviously way up here to top the graph completely. So the question on this is, what is our y-intercept? Our y-intercept is 2, but we don't have an x-intercept, right? There was never 0 people infected. We started with 2 people infected. It looks like we have a curve. It looks like it's multiplying by 3 each time. I don't think we should connect the dots, and I'll tell you why. There is part of a day, but there is not part of a person that's sick, right? So if we connected those dots, it's like saying you could have 100.76 people. Well, you either have 100 or you have 101. You'd have 100.7. So we have that data. And then I'm going to pause and write down the data for the, it says give the coordinates where x equals 3. Well, in this case, we know it's 354, right? When we get to this one, I'm going to pause and just steal the book data. So let me jot that down. Stealing the book's data, again, I didn't time myself. And I plotted those points. And something interesting happens. It looks like it wants to be linear, and it would make sense for it to be linear, right? The idea that it probably takes roughly twice as long to sign your name 10 times as it does 5 times, but probably not exact, though, right? I mean, it looks like on this data, you got a little bit faster as time went on, which makes sense. If you're signing your name a lot, you probably get tired of, and you probably go more quickly. But the bottom line is, it looks like it wants to be a line, but it's not quite exactly a line. So if we go ahead and draw a line through those points, you can see what I'm talking about. And this is something that we're going to deal with in chapter 4 of this book. It's called regression, where you want to use a line to estimate this data, right? The line's a good fit, but it's not perfectly hitting those data points. Again, this will come up in chapter 4. But if you look here, we have these 3 distinct graphs. This is a curve that goes down. It doesn't have any x or y intercepts. This is a curve that goes up. It does have a y-intercept but no x-intercept. And here we have, I guess, a line, right? It makes sense to make it continuous. You can have part of a signature and you can have part of a second, so that's okay. But the line doesn't hit these data points, which again may feel weird for now, but it's known as regression, and it's something that we'll be talking about later. And then we know that 3 ended up being 24.84. So I will close out of this and reopen it, and you can see the book had essentially the same answers that we did. I'm trying to orient myself here, so I think we're on 112D. I guess I haven't opened that yet. So we've kind of discussed all this stuff. We've gone through the problems, and I want us to focus on the math notes because there's some important stuff going on here. So first of all, the handwriting one was a linear function. It was a line, right? They can go up or down. If it's direct variation, it says another function family is called direct variation, also called direct proportion or proportional, which is a linear function that passes through origin. It too may be increasing or decreasing from left to right. So if you think about it, the handwriting one was also a direct variation because it went through 0, 0, and it was proportional, right? It was, if the x doubled, the y doubled. If the x tripled, the y tripled. So again, the data gathered in the Sign the Dotted Line lab is an example of an increasing proportion. In a proportional situation, if the x value is doubled or tripled, the y value is x valued or tripled. You could also have something decreasing, right? That curve that we had actually looked more like this inverse variation or this inverse proportion, the hot tub, right? But it's clearly going down. But we're going to call it proportion. The data collected hot tub is an example of inverse variation. As the x goes up, the y goes down. As the x goes down, the y goes up. So they are inversely proportional. And then exponential functions, and that's the curve that we had for the flu epidemic. You can see it's an exponential growth. So again, we're going to talk about this in class this year. We're really not going to spend a lot of time on this one, quite frankly. We will definitely discuss these two in class this year. So that's just a little idea of families of functions and some of the things that we'll be discussing in class this year.